All right, now let's talk about digital to analog conversion. So DAC can stand for digital to analog conversion or digital to analog converter. So sometimes DAC is used as a noun. So here we have some digital bits. Maybe this is a number stored on a counter. Maybe this is a number stored in some other, flip-flop memory or something like that. And we want to turn this into an analog signal. So this is what it would look like on a block diagram. We have these input bits, and we want to output a voltage that is ideally linearly proportional to that number. So here's one way you can implement this. We take our bits and we put them into resistors that are connected together, and these resistors are then connected to an op amp as shown. So you'll recall that this, multiple resistors as an input to our inverting amplifier, this was called a summing circuit. I think we only saw it once or maybe twice, where the output here is related to the sum of these, but it's a weighted sum depending on the values of these resistors. So we know that when we are talking about these as binary digits, they have different values, right? 1's place, 2's place, 4's place, 8's place. So if we pick the right values for these resistors, we can make this weighting exactly right to give us an output that is linearly proportional to this number. So the way that works is like this. So increasing the value of your bit decreases this resistance by a factor of 2. So yeah, this ends up giving us an output here that is, this is an inverting amplifier, so there's an additional factor of -1 in there, but it gives us an output that's proportional to this input. Or what that means in maybe a graph form is if we count up one bit at a time, like cycling through our counter or something, our output is going to increase in these even-sized steps. So each of these steps is 1/15 or of our full scale voltage. So if they're all on, that's the number 15, right? So that's yeah. So wherever this data came from originally probably didn't look like this stair step here. In other words, if we recorded some digital numbers that looked like 1, 2, 3, 4, 5, they probably didn't come from something that looked like this. They probably came from something that looked like this. So if we were going to use this, we would additionally want to take this output and filter it, probably a low pass filter, so that it would smooth out these sharp corners. And that would give us, if this was like an audio signal, that would give us audio that sounded much more like what we originally recorded. You also can have digital to analog converters that interpolate, so they can look at a bunch of these numbers at once and say, oh, well, I'm going to output a voltage that is, you can kind of think of it like a line of best fit through those or something like that. So there are ways of designing these converters that do this interpolation in addition to or instead of this type of filtering. Anyway, so again, this is just a flavor of how these processes work. You can make digital analog converters without an amplifier, just with a resistor or ladder. They of course cannot supply anywhere near as much current as the op amp version, so there are some downsides there to that. So I think that's all the more detail we need to know about these. I just wanted you guys to know that these exist and that these are some ways we can make them with these circuits that we have seen already.